Hey everyone, and welcome. Today, we're diving into a really cool quest. How do we actually measure true artificial intelligence? We're going deep inside the ARC-AGI benchmark, a test that's designed to push AI reasoning to its absolute limit. So, get this. What if the real test for an AI, the ultimate challenge, wasn't some super complex game like chess or Go with billions of moves, but a puzzle that, honestly, a kid could figure out in seconds? That's the fascinating idea at the heart of what we're talking about today. Okay, let's get into it. First up, we need to understand this ultimate AI test. It's a tool built to measure something called fluid intelligence. And what's that? Well, it's basically your ability to think on your feet, to solve problems you've never, ever seen before. It's not about what you know, it's about how you think. All right, so check this out. This is what an ARC-AGI task looks like. On the left, you get a couple of before and after examples. Your job? Look at them, figure out the hidden pattern, and then use that logic to solve the final puzzle on the right. There are no words, no hints, nothing. It's just pure abstract reasoning. And believe me, this thing is a huge gatekeeper on the road to AGI. So what is the ARC-AGI benchmark really? At its heart, it's a test built to see if an AI can pick up brand new skills. Can it solve problems it's never been trained on? Every single puzzle has its own unique logic, which means you literally can't study for it. You can't just memorize your way to a good score here. And this is where things get really interesting. When humans took this test, we basically aced it, almost a perfect score. But the AI? Whoa, the scores were way, way lower. And that just goes to show you, this isn't about raw computing power. It's about something else, something like intuition. And the gap? It's massive. Okay, so that was the initial state of play. What about now? Let's jump forward to the latest big event, the ARC Prize 2025, and see how today's top AIs are doing against this gnarly challenge. And the brand new high score is 24%. Now, on one hand, that's a huge leap forward. It's a new state of the art. But on the other hand, 24%? That's still so far from how humans perform. It really puts into perspective just how incredibly hard this thing is. So who are the wizards behind these scores? Well, big shout out to the top team, NVARC, followed by the architects and Minds AI. You can see their scores right there, making incredible progress, but yeah, still a long way to go. So how'd they do it? What's the secret sauce? Well, it turns out there was a major breakthrough this year, a new technique that everyone was using. Let's call it their secret weapon, the refinement loop. And you know what? The idea is actually super intuitive. A refinement loop is, well, it's a loop. The AI makes a guess, gets some feedback on whether it's on the right track, and then uses that feedback to make a better guess, over and over again. It's just like a sculptor with a block of marble. They make a chip, step back, look at it, and then make another chip, slowly refining it until the masterpiece appears. So let's get a little more specific. It's basically a three-step dance. First, explore. The AI just throws a bunch of different potential solutions at the wall. Then, verify. It looks at all those attempts and figures out, okay, which of these is actually getting me closer? That's the feedback. And finally, refine. It takes what it learned and starts the whole cycle over, getting smarter each time. Okay, and this is where it gets kind of wild. This whole refinement loop idea led to a totally surprising trend. People started building models that worked incredibly well with, get this, zero pre-training. We're talking about AIs that don't need to gobble up the entire internet to be smart. And to really blow your mind, check this out. One of the top models, called the Tiny Recursive Model, or TRM, it only has 7 million parameters. 7 million. When today's big models have trillions. That is just, it's insane. This tiny little model is punching way above its weight. So how on earth does it work? Well, the magic is right there in the name, recursive. The TRM takes the puzzle, makes a guess, and this is the genius part, it feeds its own answer back into itself as a new clue. It basically says, okay, here was my first thought, now can I do better? It does this up to 16 times, literally refining its own reasoning with every single pass. It's the loop built right in. But you knew there had to be a but, right? Here comes the plot twist. As amazing as these new techniques are, they've actually uncovered a really deep, hidden problem with how AI works today. A new villain has entered the chat: knowledge overfitting.
I mean, don't just take my word for it. The official report from the competition says it all, and I'm quoting here. Current AI reasoning performance is fundamentally related to model knowledge. Let me translate that for you. It means the AIs aren't really reasoning from scratch. They're just really, really good at pattern matching stuff they've already seen.
And that brings us to this idea of knowledge overfitting. Think of it as a really subtle, sneaky form of cheating. It's when an AI does great on a test, not because it's genuinely figuring things out, but because it's seen something super similar, or maybe even parts of the test itself, in its training data. It's like getting a peek at the answer key before the exam. And they found the smoking gun, for real. While testing one of Google's huge models, they looked at its internal monologue, its thought process. And look at this quote. It said, "The target color was green, which is number 3, and the pattern was magenta, which is number 6. How could it possibly know that specific number to color code? There's only one way. It had to have seen the ARC data before. It was contaminated." So, what does this all mean? It means the game has to change. The quest isn't over, it's just leveling up. Which brings us to our final section. The future is ARC AGI 3.
You know, this whole thing is a fascinating cat and mouse game. The AI developers build a faster mouse, and then the benchmark creators have to build a smarter trap. To really test for intelligence, you can't just have a finish line that stays in one place. You gotta keep moving the goalposts. The puzzles have to evolve. And that's exactly what's happening. The next version, ARC AGI 3, is going way beyond these static little grid puzzles. It's going to test for what you might call agentic skills. Things like genuine exploration, long-term planning, using memory, even figuring out its own goals. This is a whole new ballgame. And it all comes back to this really powerful idea from Francois Chollet, the guy who created this whole test in the first place. He said, "You'll know AGI is here when the exercise of creating tasks that are easy for regular humans but hard for AI becomes simply impossible." Think about that. The day we can't outsmart the machine with a simple puzzle, that's the day AGI has arrived.
Which leaves us with one last question to chew on. If intelligence itself is really just the ability to adapt to new things, will we ever be able to stop building new tests? Or is this whole quest for AGI a journey that, well, never really ends?